Good morning. Ladies and gentlemen, today we will be talking about the periodic table. Now, there are three main sections of the periodic table. Over here, from about the snail one over, or 10 over, except for hydrogen because he's special, we have the metals. In the metals we have the transition metals and the alkali metals. And over here, we have this kind of diagonal staircase section of the metalloids. And over here we have the non-metals, with these two rows being special, this being the halogens and then the noble gases. Did you end it? The metals make up the majority of the periodic table. We have over here, or all the physical properties of the metals are lustrous or shiny. They reflect light when polished. They're solid at room temperature, except for our special boy mercury, which is just right here. And they are silvery gray in color and are very malleable. Now, their chemical properties are pretty neat. They have a reaction with acids. They easily lose electrons in chemical reactions. Well, most of them do. No, just kidding, some of them do. The alkali metals easily lose metals, and some of the transition metals, but they all generally lose electrons. And most corrode when exposed to the atmosphere, which is pretty neat. Our next group are the nonmetals. The nonmetals are over in the right side of the periodic table, mostly in the top. And they are pretty neat. They are dull in appearance. Most are gases at room temperatures. They're very brittle. And then the chemical properties are they show little to no reaction to acids. They easily share or gain valence electrons because they're closer to the full octet of the noble gases. And they form acidic oxides, which, again, pretty cool. And then... One second. They contain two different groups. Our next group is the nonmetals. Nonmetals are dull in appearance. Most are gases at room temperature. They're all over, located on the right side of the periodic table. They are usually very brittle, gases at room temperatures, and they show little or no reaction to acids. They easily share, gain valence electrons, and they form acidic oxides. The metalloids are perhaps one of the more interesting groups on the periodic table because they show both characteristics of metals and nonmetals. Metalloids are generally good conductors of electricity, but they're also very brittle, which makes them not metals, and along with other stuff too. They can look like metals and have luster, but still not metals. All the metalloids are over on the kind of diagonal right here of the periodic table. You have boron, that one, germanium, arsenic, antimony, and tellurium are all metalloids. Good afternoon, class. Now we're going to go over each specific of the four families in the periodic table. We're going to start off with the alkali metals. The origin of the group name is the word from the Arabic word alkali, meaning from ashes, which, since these metals react with water to form hydroxide ions, they kind of make ashes. They're found right here on the periodic table. So one group. They have one electron in the outer shell, which makes them very reactive because they're so eager to lose one electron and then become, then they have a perfect outer shell. The more reactive they are, the further, or they become more reactive as you go down farther. So like lithium is only a little bit reactive, but francium, well, we don't talk about francium. The next group on the periodic table are the transition metals. English chemist Charles Burry called the inner group on the periodic table, right here, in transition, because they transition from being really not stable to like kind of pretty stable to a little less stable, but because these ones are only stable because they don't really want to give up so many electrons, they kind of bond with other ones, but we'll get to that a little bit later. They have high melting points and boiling points, a lustrous metallic appearance, silver to gold and white to gray. They tend to form complex compounds in which a group of atoms cluster around a single metal atom, otherwise known as complexes. They can have valence electrons in more than one energy level, which is pretty cool, because that means that they can oxidize in 3 different states. And 3 notable elements are cobalt, nickel, and iron, which are the only elements to produce a true magnetic field. Our next group are the halogens. They are called halogens because they're from the Greek word for salt producing, as they all can produce sodium salts. Halogens are not found in their basic forms in nature, these are the halogens, because they are so reactive. So if they were found in nature just by themselves, they would be too reacting. Some are diatomic, like chlorine and bromine and iodine. So I guess they're pretty much all diatomic. They go in 2s. Adenine and tenzene adenine is on here, but tenzene is on here, I believe. They are on this because they are so short-lived. They are only radioactive. I don't know the word, isotopes. Fun fact, fluorine gas is so deadly that breathing in a 1 part fluorine gas to a 1,000 part other gas is deadly. The noble gases are our perfect boys. They are stable with a full shell of valence electrons. Very low reactivity because of the full shell. The entire group of noble gases was added to the periodic table when William Ramsay discovered argon. Our bud right here. Argon. Which didn't react with anything. He then predicted, based off of the current periodic table, that there were other perfect elements. All of the noble gases are gases. Odorless, colorless gases. With almost 0 chemical reactivity.
I'm Hannah. This is my emotional therapy dog. And I'd like to welcome a few guest speakers for today. Yeah.
Hello, boys and girls. I am copper, the greatest transition metal. My atomic symbol is Cu, and I have a molar mass of 63.546. I've been known to man since 5000 before Common Era, and I've been protecting y'all in the form of shields, swords, and helmets since my discovery. Currently, though, I am very important in electronics, as I am a wonderful conductor of electricity. As you all can see, I have a beautiful reddish-brown color, and I'm so lustery and gorgeous. Of course, everyone wanted me to be the penny. Less than 3. Oh, and don't forget, my number is 29, so I'll see you later. Hi, I'm sodium, atomic number 11, atomic symbol is Na, and my atomic mass is 22.98707. I'm highly reactive, so I've been classified as an alkali metal. I don't really like being alone because I never know what will make me react, so I can only be found naturally within a compound, like a friend group. I'm the 6th most abundant mineral on the planet, and I make up 2.6% of air, water, earth, and fire. I'm more popular than copper, so that's pretty neat. Currently, I'm in a ton of foods. Your table salt is NaCl, which is me and my buddy chlorine. Hey, I'm helium. My atomic number is 2, and my atomic mass is 4.002602, and I am one of the neat noble gases. I have a full outer shell of valence electrons, so I'm very unreactive. I am a colorless, odorless gas, and I was first discovered by William Ramsay. My name, helium, comes from the Greek god Helios, meaning sun. I'm the 2nd most abundant element in the universe, and I'm still being created by alpha decay particles on Earth. Currently, I am used by divers in an 80% helium, 20% oxygen mix, and I have been used to detect leaks. If you have ever gotten an MRI, I provide cooling to the superconducting magnets. I am also used to make balloons float.
You'll float too?
Hey y'all, I'm nitrogen. My atomic symbol is N, atomic number is 7, my atomic mass is 14.037. I've been using compounds since the fairs have ruled, and I was first discovered on my own by Henry Cavendish and Joseph Priestley, but neither of them thought I could actually be my element. As you see me now, I am in my solid form, also known as dry ice, and I am giving off a lot of steam. I am found in all living things, and I am an important part of the biological nitrogen cycle. I'm the most abundant element in the air. Chances are I will definitely save your life, as I am an important compound in airbags. It was nice meeting y'all. I hope to see you again. What's up? I'm silicon. My atomic number is 14, my atomic symbol is Si, and my atomic mass is 28.085. I'm one of the useful elements in more useful elements in mankind. I can be used to make dynamite and transfer plates, along with engine blocks. Johns Jacob Berzelius obtained me by heating potassium fluorosilicate with potassium. The product was contaminated with potassium silicide and silicon. I make up 27% of the world's crust, so yeah, I'm pretty cool. In modern day, I'm currently used in most electronics, and the thing that we're filming with right now, that phone, it has a silicon data chip inside because I'm just that cool. I am a metalloid, so I have metallic features, as you can see. I'm very bright and shiny, and I can conduct electricity, but I'm very brittle. See, watch what happens when you try to bend me. It just rips and breaks. How terrible is that? Alright, I'm boron. Atomic number 5, and I'm a semi-metal along with silicon, and my atomic mass is 10.81. When I'm in my pure form, I'm a dark powder. I'm used in borax, eye drops, mills, anesthetics, and some flame retardants. I'm important in the cell walls of plants, and while not poisonous to humans, too much of me can mess with your metabolism. I'm being studied as a potential treatment to brain tumors. When I'm in the BH3 compound, I can be used to turn alkalines into alcohols. I'm almost impossible to render 100% pure. It's been wonderful meeting you all today. Thank you very much.